So notice on example 7, number 68, that we have a quadratic equation, but it contains some fractions. Up above, it says if a quadratic equation has fractional or decimal equivalents, we have the option of clearing the fractions or the decimals by using our multiplication property of equality. And I think that's what we should do here on number 68 before we even get started. Again, even though this is almost written in ax squared plus bx plus c, well, we'd have to do a little bit of reorganizing. What I do want to do is clear fractions by multiplying through by the least common denominator, and I think a 6 is going to cancel all of those out. So I'm going to multiply each of these terms by 6. Now, when we go to reduce, the 3 and the 6 will reduce, leaving us with 2x squared. Here, the 6's reduce, so we have remaining minus 7 equals the 2 and the 6 reduce, and so the 3 times x times 3 gives us 9x. Almost forgot to say x, 9x. Now again, we need to get everything on one side equals 0, and we can accomplish this by subtracting 9x from both sides of the equation. So we're going to have 2x squared minus 9x minus 7 equals 0. Now again, let's pick out the a, the b, and the c. The a value for this equation is 2. The b value is a negative 9. It's important you bring those signs with that. Okay? And the c value is a negative 7. Now, when we use these values in our quadratic formula, let's do that right over here. This time my variable is x, so I get to have x is equal to negative b. Now that's going to take the opposite of negative 9, that's the negative b, plus or minus the square root of b squared. What I like to do is I like to calculate that b squared kind of in my head. I like to do negative 9 squared. 81. Okay? So that's going to be b squared is 81 minus 4 times the a value of 2 times the c value of negative 7. All over 2 times the a value. Okay? Now it's a matter of cleaning this up. But what the beautiful thing is that this quadratic formula gives us our solutions for x. Okay, so our answers, when we did the opposite of a negative 9, that makes that be positive 9. And so the negative b term in the quadratic formula, you can think about that as being the opposite of b. So whatever your b value is, you end up taking the opposite of it. That's why this is a positive 9. And of course the plus sign isn't necessary, but I'm just going to write it for emphasis. I'll drop it here in a minute. So we're going to have positive 9 plus or minus the square root of something all over 4. I like to write it like that and then go back and focus on what's underneath the radical to get that simplified. Okay? So underneath the radical, we've got 81. And then when I take negative 4 times 2, that's negative 8. Negative 8 times negative 7, I'm going to be adding 56 to 81. And 81 plus 56 gives us 137, I believe. Now, we could be finished here. I tell you what I do want to do is take off that little plus sign. But before we can be confident that we're finished, we do want to see if the square root of 137 breaks down. Now, that's not going to be an I like it was on the last example, like when we got 6i, because that's a square root of positive 137. But I do want to think about if, let's see, I'll go over here. If the square root of 137 will break down into the square root of something times the square root of something, such that this is like a perfect square underneath here. So we're going to see if there are any factors of 137 that are perfect squares. So you take 137 divided by 4. Nope, that's a decimal. 137 divided by 9. Nope, that's a decimal. 137 divided by, and you try that out. Okay, you try all those possible combinations. Nothing works, so square root of 137 is as simplified as it gets. Here's your answer. Now, writing that as a solution set, okay, it's going to be 9 plus the square root of 137 over 4, and 9 minus the square root of 137 over 4. And of course, you could write that more compact with the plus and the minus. But again, this time we do have conjugate pairs, but those are irrational conjugate pairs. Those are real numbers that happen in there. Now, this is a good place to talk about, yeah, that's the exact answer. But what in the heck are these numbers? If we were going to estimate what these are, like say round to the nearest tenth, perhaps, I would come over here on my calculator. Let me pull that up. And I would ask my calculator, what is 9 plus the square root of 137? And then I'm going to divide that by 4. So I better hit equals first, okay? And then say divided by 4. And to the nearest tenth, that gives us about 5.2. Let me see. That gives us about that this one is about 5.2 to the nearest tenth. On your calculator, you do need to be a little bit careful. You don't just want to say, watch this, 9 plus the square root of 137. Let me even cursor outside of that radical. And then go divided by 4, because all it's going to divide by 4 is the square root of 137, and this is all divided by 4. So that's incorrect. You can do the whole thing if you use your parenthesis key, and you'll have 9 plus the square root of 137. The 1, there we go, 137. Let me cursor out from underneath the radical and close the parenthesis out for my numerator, and then divided by 4. That should give us the correct answer of the 5.176, okay? And so when we're going to estimate the other solution, what I like to do is I like to cursor up here on a calculator like this and then grab it. And then you're going to be able to just edit a little bit. So I'm going to cursor back, and I'm going to change that plus sign to a minus, because I want to know what is 9 minus. I totally messed something up there, didn't I? I got it over the wrong thing. 9, there we go, minus the square root of 137 over 4. And to the nearest tenth, that is about a negative 0.7. Negative 0.7. And so if you're ever asked to give the solution set rounded to the nearest tenth, 5.2, negative 0.7. Okay, that's a little bit better. But most of the time, what we really want is the, whoa, oh no, what did I do? We just really want this exact answer. Oh, that blue marker on this stupid board isn't working. We want that exact answer. That's what we want to give. Ah.